Okay. By the way, if you ever see that I've said I'm going to start recording and I haven't, send me a message or just tell me, don't forget to record. I'm sure that classmates will appreciate that. Okay. Okay. So yesterday we talked about algebraically, how do we find out the particular limits? And what we said was that we should always try substitution first, meaning let's just plug in the number, let's see what happens. And if we can get a number out, then that means that that is the limit. And in particular, what we're going to have is we're going to have a continuous function, which we'll talk about more later today, okay? But try the substitution first. No matter how gross the function looks, plug in the number, see what comes out. If you get a number, you don't have to do any more work, okay? And then we talked about some situations where, well, maybe we plugged in the number and it gave us a 0/0 or an undefined situation, okay? And so we said that if we got 0/0 when we plugged in our number, that meant that we had an undefined situation. And yes, perfect. And in particular, we had a hole in our graph at whatever x value we're looking at. And so what that looks like is, it looks very much like this as a picture, where you've got a continuous piece, and then there's a hole, one point that has been plucked out and thrown away, okay? And so what we're gonna do now is practice a little bit more factoring, get those brains warmed up early in the morning. And so let's take a look at example number 6 over here. And let's be cautious first. Let's first plug in our number and see if we have to do any more work, okay? So the number we're gonna plug in this morning for example number 6 is a -3, okay? And we know that because we have that -3 right there. And so everywhere I see an X, I'm gonna go ahead and plug in a -3. And I like to aggressively put in more parentheses than I think I might need. Yep. And it looks like a lot of us are in the right direction. And so let's just make sure we are, we get, what do we get? 9 minus 9, excellent. And then 9 plus 3 minus 12, which indeed does give us the 0/0. Perfect. So excellent job for folks who got there before I did, but we do in fact have an undefined situation. And so if we were to think about what this means, that means that on this particular function, x squared plus 3x over x squared minus x minus 12, we have a hole at what point? Where do we have a hole here? X equals -3. Good, good, good. All right, so we're on example 6 and we have a hole at x equals -3 because when we plugged in -3, we got undefined. Okay, and so that's sort of the concept that I want us to connect. Not just that, oh, I can factor and oh, I can plug in a number, but like, what does our number actually mean? Okay, so once we get the undefined, that is a clue for us that we need to do something different. And so when we see things that are sort of quadratic in nature, that might be an indicator for us that we should go ahead and factor, okay? So we're gonna go back here. Now, I do want us to be careful and make sure we continue to write this LIM in the front until we've actually plugged in the number, okay? And so we need to keep this part in the front. But what does the numerator up here, x squared plus 3x, what does that factor into?
X parentheses x plus 3 over x plus 3 parentheses x minus 4.
Yeah, perfect, perfect. So we've got x over or times x plus 3, thank you. And in the bottom, that x squared minus x minus 12 does indeed factor into x plus 3 times x minus 4, okay? Now we see something here that should be a clue for us that we are headed in the correct direction. What is that clue? After we factored, how do we know that that was a good strategy to use?
Because you can simplify.
Okay, I heard a couple things. Yeah, I heard someone say we could simplify. Exactly, those x plus 3's can cancel. We see the same factor in the numerator and the denominator. Excellent. So we see that x plus 3 and that x plus 3. So we can reduce those, okay? Let me ask you a question. Can I do this?
No.
No.
Okay, I'm so glad we all said no. Okay, that is one of the situations where I feel like sometimes we're like, oh, just canceling, and oh, I get 1 over -4, right? But we need to be really thoughtful that the things that we're reducing all have to be sort of multiplied together, okay? And so what we end up here with is indeed the limit as x approaches -3 of x over x minus 4. And when we plug in our number now, okay, exactly, Vincent, because that x is a different factor than x minus 4, all right? Now, when we go ahead and substitute our number in, let's see, because if we do not yet undefined, that means that we're good to go, okay? So we plug in our -3 over -4, or 3 minus 4. And this is -3 over -7. And I saw that someone had this earlier, that reduces to 3/7. Okay. So what does that 3/7 mean? We get to the end, what does the 3/7 mean?
It means that despite the whole, we actually do know the limit. Limit has a value of 3/7.
Yeah. So we know there's a hole. We know there's no actual value there. However, 3/7 is the y value that we approach. Okay, so as we get close to an x value of -3, we're going to get a y value of about 3/7. Okay. All right, are there any questions on example 6? Oh, I see one in the chat. Is it only undefined when both the numerator and denominator are 0? Or is it whenever the denominator is 0 during substitution? That is a great question, Catherine. So in particular, what we're going to be seeing a lot is right now we're focusing on the 0 over 0 case, okay? In a couple days, maybe like Wednesday or Thursday, probably Wednesday, we will take a look at what happens when we're only having 0 in the denominator, okay? And that's going to look different on a graph. And so we're going to have a different strategy to approach that, okay? So for right now, let's focus on that 0 over 0. All right, perfect. I love it. Okay. All right, let's take a moment. I'm going to have you go ahead and take a look at number 7. Okay. Let's see, do we need to use factoring here or not? And how do we know? And if we do need to use factoring, let's go ahead and factor. Okay, so let's take a couple minutes and kind of work through this. I'll give you a little bit of a head start, and then I'm going to start putting my work up on the screen so we can kind of compare and see what we get. Okay. All right, Vincent, you got 0 over 0. I got 0 over -6. What happened? Ah, it's a +2. Excellent. Okay. So as we're moving through problems, and I can see this happening to folks on an exam, right? We might move through some things a little bit too quickly. So it's always worth kind of double checking your work, right? So if we see a -2, -1, very clearly I should have a +2 here, right? And so I'm going to go ahead and fix that, make that a +2. And any other mistakes that I have? It's a +1, exactly, right? And so this -1, when I square it, sometimes students get -1 when they square it. And I think that comes from if you're typing it into a calculator and you don't put the parentheses around it, your calculator thinks you want to square it and then make it negative. Okay. And so I think by this point, we know anytime we have a number, whether it be positive or negative, and we square it, we'll get a positive number. Okay. And so when we double check our arithmetic, we get 1 + 2 - 3 does indeed confirm Vincent's answer and Johanna's answer that we have an undefined situation here. Okay, so great job, folks. All right, now that means that when I look at the question, I see some quadratic things. And when I see quadratics, I'm like, maybe I should factor. Okay, so let's go back to our question. Limit as x approaches -1. And what do folks get when they factor the numerator? Ooh, already in the chat. Perfect. And the denominator. Okay. So the numerator does indeed factor to 2x. And then we have an x. And we have +1, +1. Okay. And the denominator, x - 3, x + 1. All right. So one of the first clues for using factoring was we saw quadratic expressions, but this next step should be a confirmation that, x + 1 and x + 1, those reduce, right? So the point is something should reduce. So if we get to that step we factored and nothing is reducing, it's possible that we factored incorrectly and we should check again. Okay, so that's what I would encourage you to do. If something's not canceling out, it's possible that you didn't factor correctly. You just need to go back and check it again. All right. So now let's go ahead and plug in our number. We're going to plug in -1 into 2x + 1 over x - 3. And we'll get 2 times -1 + 1 over -1 - 3. And let's see, that gives us -2 + 1 is -1 over -4. And we get 1. Perfect, perfect. Okay. So let's kind of squeeze these 3 factoring ones on one screen so we can kind of see here. But if we were to think about a pattern, one thing I would want you to notice is that every single one of these questions has at least one quadratic expression. Okay, so when we see quadratic expressions, it could be top and bottom, all right? But it could also be, like we saw in example 5, only in the top. All right, so it's not that it has to be quadratic everywhere, it just means that we have to have quadratic somewhere, okay? Down here, there is a little space that says, how do I know when to use factoring? So take a moment, think about a way that you might want to summarize that for yourself. And if we have any folks in the classroom who'd like to share their how do I know when to use factoring, you can go ahead and type that into the chat. That way folks can kind of see more than one way of thinking about this, okay? So take a moment, let's think about how we would write our own, how do we know when to use factoring? And again, if you feel so called to contribute, go ahead and share what you have in the chat as well. All right, I love this. So when the substitution method outputs an undefined, good, okay. So that's gonna actually be one clue, but we're gonna find some other cases where we get undefined and we're gonna choose a different method, okay? So these are great starts. All right, when plugging in an X value results in an undefined answer, use factoring, okay. Okay, and the expression contains at least one quadratic. Good, a whole exists and a function can be simplified. These are all great, okay? Now I'm gonna say, let's keep what we have written down. Let's try this next piece. And if we need to come back and modify our strategy as we learn more, we'll modify our strategy, okay? So everything that we have so far is really great. Let's think about how we might be more specific once we see some other cases that are happening, okay? All right, before we move on to the next type, does anyone have any questions? Okay. Will we be given a huge number and asked to factor it? Yes, I plan to use the worst numbers on your exam. No, I'm just kidding. I think that it is important to be able to factor. Definitely one that coefficient is a 1, but also if that coefficient is a 2, maybe a 3 or 4 or 6. So I don't think anything super big, but we should be able to factor even when that first number is not a 1. Does that clarify that? Exams, so okay. So as far as exams, let's maybe save that for after the break. Let's kind of see if there are any questions. We'll talk about the extra credit. We'll talk about the exams, things like that. How's that sound? Okay, well, I hope it sounds okay. All right, so let's go ahead and check out one more strategy and then we will take a break after that, okay? Would x plus 1 over x minus 1 cancel out? Let me just write down what you're saying to make sure I've got it correctly, Noah, okay? Are you asking if x plus 1 over x minus 1, if those would cancel each other out? That's a great question, okay? So they would not, because what we need to think about is there are actually imaginary parentheses around here, right? So the entire thing inside the parentheses needs to look exactly like the other thing. And so as soon as you put the parentheses on it, I think it becomes more obvious that the top is very different from the bottom. Okay, so they would have to match like perfectly, like x plus 1 and x plus 1, or x minus 1 and x minus 1. Perfect. Okay, great question. All right, so let's move on to another classic case of what happens with limits and how we might be able to solve things. And so I know I have this one as example 1, but I'd actually like to start with a more simple example here. We're actually going to start with example 9, okay? So let's go ahead and take a look at example number 9. Now, this one has a square root in it. I don't see any quadratics, so we're probably not thinking that we want to factor. How do we find a denominator in example 7? What do you mean by find a denominator?
How we get this number x minus 3 and x plus 1? I can do it by guessing, but there's a formula I forgot.
So we're not going to be using a formula, but we're going to be using the concept of factoring. Okay, so I will say that if you folks who have been very reliant on the quadratic formula, that's actually not going to help us here. Okay, so what we want to do is do some factoring. But if you have questions on factoring, that would be a great time to maybe reach out to me on Discord or send me an email, and I'm happy to send you some resources on the factoring. Okay, and we will do a little activity on Thursday as well to sort of freshen up on the factoring. All right. Okay, so example 9 we're looking at, right? Looks a little bit different than the ones we've seen before, but the first thing we should always do is we should try plugging in the number, right? No matter how gross it looks, we need to go ahead and plug in the number, see what happens, okay? So this time I'm gonna see everywhere I see an X, I'm gonna go ahead and plug in 9, and let's confirm Matt's answer that it does yield a 0 over 0, okay? So we get square root of 9 minus 3 over 9 minus 9. All right, we get 3 minus 3 over 9 minus 9. Yeah, we get that 0 over 0, okay? So we do get an undefined. All right, so we get this undefined. That doesn't mean that the limit is undefined. It means we need to do some algebra to help us figure out what it becomes, okay? So let's see, does anyone remember way back from like pre-calculus when you had like, let's say 3 plus I like the imaginary number. And sometimes you actually had to multiply that by something that looks very similar, 3 and an I, except it was a minus sign in between.
It's the conjugate.
Okay. So sometimes we recognize what things look like, right? We had this pair. They looked very similar, but the sign in between was different. And exactly, okay? Just like Matt said, just like Kristen said, these are called conjugates, right? And so this is not the kind of conjugate we're going to use here, but there is sort of a conjugate when we look at square roots as well, okay? And so our strategy here, oh goodness, our strategy here is going to be to take our original and we're going to multiply by the conjugate. Okay. But the question is, conjugate of what? All right. And this is going to be incredibly important. We need to make sure we multiply by the correct conjugate. Okay. And so we are going to multiply by the conjugate of the radical of the, let's write this better, expression with the radical. Okay. So that's how we're going to choose. All right. It's not always the top. It's not always the bottom. It's based on where the expression with the radical is. Okay. So in this case, we have our radical in the numerator. All right. We have square root of x minus 3. What is the conjugate of square root of x minus 3? Square root of x plus 3. Okay, so square root of x plus 3 is what I'm going to multiply by here, but I don't want to change the question. Okay, this is a very incredibly important thing in mathematics. I don't want to change the question. How can I guarantee that I'm not changing my question?
You divide by square root of x plus 3.
Exactly, exactly. So this term that I'm writing here, okay, this is the fancy way of multiplying by 1. Okay, fancy way of multiplying by 1 using conjugates. All right. So exactly, Matt says it really well. Same numerator, same denominator. Okay. And Catherine, do you use this every time there's a radical in equation? Yes. And if you see a radical and you plug in the number and you get undefined. Does that make sense? Like, I really want you to try that first, because if I plug in a different number, I might not get 0 over 0, and I might not need to do any of this hard work. Maybe all I need to do is plug in the number. Okay. So as long as in your head, you're like, always plug in the number first. If I get 0 over 0, then I do these other things. Then I think that's a fair statement. Okay. Jenny, sorry, I missed your chat with the other method. If we look at a limit and we know which method to use, is it necessary to substitute? Yes, I would say this early in the game, I think it's important to substitute because you might not get 0 over 0. So if you don't get 0 over 0, you don't need to do any of this. So if you plug in it and you get a number, you're fine, you're good to go. That's just substitution. So we can do substitution with radicals. We don't always have to use conjugates. The only time we need to use the conjugates is if we get 0 over 0. Does that make more sense? Okay. All right. So let's see what this conjugate does. Okay, let's see what this conjugate does. So when I have this conjugate, what I'm going to do now is I'm going to simplify. But when we were working with the factoring, simplify meant cancel out. And this time, simplify means we're going to actually multiply our two fractions together. Okay. So when we multiply fractions, one important thing we want to keep in mind is we're just going to multiply directly across. Okay. So numerator times numerator, denominator times denominator. And if I write that out, I'll get root x minus 3, root x plus 3 over x minus 9 times x plus 3. Okay. Now I want to say something very important here. And that is that if you used the conjugate of the numerator, you're going to multiply that out. Okay. So in our case, we have our conjugates up here, root x minus 3, root x plus 3. And we're going to multiply this out. Okay. Now, is the bottom a conjugate pair? Like x minus 9 times square root of x plus 3. Is this a conjugate pair? It is not, okay? If it is not a conjugate pair, do not multiply out, okay? But it's based on the conjugate pair. And here's why. When we multiply things out, the numerator, let's see what we get. What's square root of x times square root of x?
X.
Yeah, square root of x is times square root of x is just x, right? I want to write this next part out because I think it makes people nervous sometimes. But when I take the square root of x and I multiply it by a positive 3, what do I get?
3 square root x.
3 square root x. Okay. Now I have folks who are like, I don't know what it is, so I'm just not going to write it, but if we can't simplify it, we can just write 3 root x, okay? What about the inner terms? What does that give us?
Minus 3 square root x.
There you go, okay? And then negative 3 times positive 3 gives me a negative 9. And we have that same denominator here. Okay. Now the beautiful thing about the conjugate, what it does is you might notice that these two middle terms, positive and negative, they're going to go away. Well, why does that matter for us? Why is that so cool? That the middle terms. Yeah, go ahead.
The radical, because you're taking the radical out of the denominator.
Exactly, exactly. X minus 9. That's what I have in the numerator. Perfect. And now, maybe it would be helpful if we put those imaginary parentheses around there. We have the same factor on the top and the bottom, and that is always magical because then we can reduce. Go away, go away. Okay. Well, what do we have left? True or false?
False. That's in the denominator.
Ah, thank you. Okay. What mistake did I make though?
I mean, you could have written a 1 after you canceled the x minus 9. That might have reminded you to leave it in the denominator.
Exactly. So I think one of the things that makes math really tricky is like, there's these imaginary numbers that you're not imaginary. There are these invisible numbers that you're supposed to just know are there. So sometimes when I reduce, I actually replace it with a 1, just like Matt suggested, so that I remember there's a 1 on the top and this is in the denominator, like it's on the bottom. Okay, so if I write it just as root x plus 3, I've completely changed my problem. I don't want to write that. I want to write 1 over root x plus 3. All right. Now let's plug in our numbers. Let's see what we get. 1 over square root of 9 plus 3. And this will give me 1/6. Yeah. So let's get this all on one page so we can kind of see it. All right. What are our thoughts so far? I see some questions in the chat, but let me give everyone some thought or some think time to kind of see how they're feeling about this.
Professor, I have a question about you said the conjugate of a numerator, you use multiplication. So if it's a conjugate of a denominator, do you use division?
So we're going to do that in example 10. When we see the conjugate of the denominator, all that means is we're going to multiply out the denominator, not the numerator.
Okay.
Okay, great
Okay.
question. Kristen, okay, so let's kind of go back to the picture for a moment, okay? So, okay, so this was sort of the very first picture we looked at yesterday. Now, if we were to look at this hole right here, okay, this one, I bet if whatever this function is and you plugged in x equals negative 3.5 and you just do substitution, you would get 0 over 0. So when we find the limit though, we're really saying what value does it get close to? So it doesn't matter that the actual value is missing, but this y value, like that's really close to it on the left, might be about 1/2. This y value might be really close to 1/2. And so we can see that from both sides, they're like getting really close to the same y value. It's almost like factoring tells us what would that y value have been if we didn't have a hole. Does that make more sense? Okay. Yeah, so anytime we see these 0 over 0s, we are thinking there's a hole in the function. I don't want the actual y value though. I just want to know what it's getting really close to. And so we'll see that it has like, it's getting really close to 1/6, okay? So let's do this. Let's do example 10. And then I'm going to show you another feature of Desmos that you don't have to be in the class for, but if you've never played around with Desmos, it is one of the most amazing mathematical tools to kind of come out of the last decade, I think. So it's completely free and you can do so many things with it, okay? So let's take a look at this question. And all right, let's see what happens. All right. So first step here, what should we do for example number 10?
Substitute.
Substitute. All right. So we're going to plug in -1. Let's see. -1 over 3 minus square root of -1 plus 9. That gives me -1 over 3 minus square root of 8. Okay. Do I need to use conjugate? I see one no.
No.
Okay. So this, I think, is a great example of what folks were kind of asking about earlier, right? Which is, we have this, I plugged in the numbers, but I didn't get 0 over 0. I got a really disgusting number, but that's fine. Nobody said I have to know exactly what that value is. I can just sort of leave it in this form and it's completely okay. All right. So because I don't get 0 over 0, substitution totally works. All right. But I'm wondering, let's make an example 10.1. And I'm going to keep the same function, x over 3 minus square root of x plus 9. And Matt, no, that's fine. I think it's okay. If you want to write it as 2 root 2, that's absolutely fine. I think that's a handy value to know. I'm not super picky about like that kind of simplification. So either way is fine. Okay. All right. So I'm wondering if we can play a little what if, all right? I want you to tell me what number I should put right here in order to make this a question where I have to use conjugates, right? Okay, let's give that a try, all right? So if you're like, how do folks know? Sometimes we just kind of need to play around with values and see how can we get 0 over 0, right? That's the goal. If we can get 0 over 0, then we can use the conjugates. So let's plug in 0 and let's see. 0 on the top, that's a good start. 3 minus 0 plus 9. All right, we do get 0 over 0 this way. Okay, and so the question looks so much like the other one, except instead of a -1, we put a 0 here. So it's so important to look at what that little number is, because I don't want you to do more work than you have to. If all you have to do is substitute, just substitute, that's fine. Okay. I also want us to know what it means to get that 0 over 0. All right. And so when we do that, it means that we actually are missing that particular part of the function. Okay. So let me go ahead and do this. Let's work through this problem. I think it'll be a little bit more time efficient if I pull up the graph while we're on break, and then we can look at that when we come back, okay? So we have this. If I want to use conjugate, I'm going to set up this, and I'm going to multiply. Ooh, I'm going to multiply by some fraction, okay? And so who was it who asked that excellent question? I think it was Catherine. In this case, all right, in this case, I know I want to use conjugates because I have a square root. I know I want to multiply by 1 because I don't want to change the problem. Do I multiply by the conjugate of the numerator or the denominator?
Denominator, I guess.
Yeah, that denominator, the bottom one, exactly. Okay, so I'm going to go down here. And what is that conjugate? All right, let's think carefully about that. What is the conjugate of 3?
Square root of x minus 9.
Okay, I missed that first part. Can you say that first part again?
Oh, so as 3 plus square root of x plus 9.
Okay, so I just want to point out one of like the most common mistakes that I see, which is that when folks are multiplying by the conjugate, they just kind of change all the signs. You see how that's different from what folks have in the chat, right? I went ahead and changed every single sign in here. but I don't want to do that, okay? Let's think about the sign we actually want to change is going to be the one in between the number and the radical. Everything else stays the same, okay? So this minus does become a plus, but I'm going to keep the plus x plus 9. Okay, so the only thing that changes is just the sign in between the two things, not all of the sign. And we want to make this a fancy one. We have this. And now we're going to multiply. Okay. Am I going to multiply out the top or the bottom or both?
Only the
I think
bottom.
just the bottom.
Yeah. Okay. So if you are listening to these questions, all right? So part of the reason I'm asking these questions is I want us to be able to ask ourselves these same questions as we're moving through a problem. So totally fine if you're like answering in the privacy of your own home, but I do want you to make sure you're listening to those questions, okay? So when we're thinking about this, I see a few answers here. I see some folks saying both, the bottom, just the bottom. Okay, so let's maybe go back out up to this example. So we want to think that we're going to multiply out wherever we have the conjugate pair. And so in this last case, it was square root of x minus 3 square root of x plus 3. That was our conjugate pair, so we're going to multiply that out. But if it's not our conjugate pair, we do not want to multiply it out. And so if you are a color coding fan like myself, if we were to look at this, I think that we'll notice that we do indeed have the conjugate pair on the bottom. So we're going to multiply out the bottom, but I'm going to ask you to be patient and leave the numerator just the way it is, okay? I think that we maybe all had one math teacher in our lives that were like, I want you to simplify everything all of the time, just simplify it. And that's like a big question that students have, like a totally valid one. How do we know when to simplify? And one of the things that as we get up into higher level math, that's really important to think about is when is it going to be useful to simplify? When is it not? Okay. And so let's go ahead and write out here. Do not multiply anytime we have no conjugate, but a multiply when we do have that pair, okay? And let's see what we get. Okay. Now, I am going to take a little bit of a shortcut here, okay? I will talk to you about where this comes from, but when we looked at our last question, I said, let's write out every single step. And we noticed that the middle two terms canceled out, okay? If we think about our conjugate pair, okay, the conjugate pair is used because our middle terms will always cancel out. So what we're looking for is we're just going to multiply the first terms and we're just going to multiply the last term, okay? Meaning we've got 3 times 3, whoops. So I'm going to get 9 minus square root of x plus 9 times square root of x plus 9 gives me x plus 9. Okay, And so let me leave a little note. This is the first terms multiplied. This is the last terms multiplied. Okay, so first terms and last terms, you don't need to multiply out the middle ones because they're gonna go away anyway. All right, so you can write them out and you will see every single time that they're just gonna go away. All right, so if it makes you feel better to write them out first, that's okay. If you feel comfortable sort of skipping to this step, that's also okay. All right, what can we do to clean up that denominator a little bit more?
We can distribute the negative one through the second term.
I love that. I love that. So we've got 9 minus x, and then it's going to be a minus 9. Perfect. Okay. Now this is going to give us the limit as x approaches 0. We've got this on the top. And what are we left with on the bottom?
Negative x.
Negative x. So wonderful. Okay. What happens when I reduce now? Because a lot of times we're like, we just cancel, everything goes away, right? But this time when we reduce, we actually have a -1 left over, right? X and x, those reduce to 1. But x and negative x, that reduces to a -1. Okay, so we need to be really careful about the accuracy of our work. Especially when we're going to be plugging in numbers and doing more stuff with it later. Okay. So I think we're at a point where we can go ahead and plug in some numbers. And we've got -3 plus square root of x plus 9. Is this okay? I just got rid of the fraction. Is that okay? Because last time it wasn't.
As long as you maintain the negative, because it's all over 1.
Exactly, exactly. We have, this is over 1, so we don't have to write it as a fraction. That's like if someone said 5 and you're like, well, 5 over 1, it's the same thing, right? So we don't have to write a fraction in that case. But let's see what happens when we plug in our number. -3 plus 0 plus 9, and that's going to give us -6. All right. So a little bit of a different flavor than the first question, because we had to think about what does it mean to not, to find that conjugate. Sometimes the conjugate is going to be on the numerator, sometimes it's going to be on the denominator. And that is precisely why I want us to think about which conjugate do I use, okay? So how are we doing here? Questions, concerns?
Professor, so whenever you're switching with the conjugate, you switch the sign of the conjugate that is the radical.
Yes, yes. Exactly. So if wherever the radical expression is, that's the one you want to use the conjugate of. Okay. Kristen, great observation. It is not a coincidence, but I think that is something that maybe in a couple of weeks we'll sort of explore a little bit more deeply. Okay. Great question. Noah, so do you conjugate when there is a radical or when it is undefined? Okay, so it's kind of a both. All right, so we want to plug in a number first every single time. And so when we plugged in the number for the regular example number 10, when we plugged in -1, we got a number out. So this as weird as it looks, is the answer for question number 10. Okay, so we did substitution and it worked. The only time we need to use conjugates is when we get to that undefined piece. All right. So if you get to an undefined, if it has a radical, then you want to use conjugates. However, when we got to undefined before and we had quadratics, then we had to use factoring. Does that make a little bit more sense? It's a lot of decision making. I get that. Okay. All right, so it is about 8 o'clock. Seems like a, oh, okay, one more question. Is it okay to have radicals in the denominator here? I see what you're saying. In the answer, yes. So this is another thing that for better or for worse, I'm not super picky on. You probably had a instructor at some point who was like, you need to rationalize the denominator. You could, it wouldn't be wrong, but I think look at how much work we already have here and how many decisions we're already making. If you want to take that extra step, that's fine. But I think if you're like, ooh, this is already a lot of decision making, I don't want to, I would rather you focus on the calculus decision making than all the little algebra pieces. Does that make sense? Okay. I mean, I won't be mad about it if you rationalize the denominator, but yeah. Okay. All right, so it is 8 o'clock. Let's take our first break. Let's come back at 8:10. Okay, hopefully that's enough time for folks to get coffee if they need. When we come back, I'm going to show you a graph of some of the things that we've been looking at, just so we can figure out how to use Desmos a little bit more to our advantage. Again, it's a free, totally awesome math resource that I think we should all know how to use a little bit, because I think it helps out quite a bit. All right, we'll look at some pictures and then we'll dive into some fractions, yay. And then we'll see how far we get, okay? So I'll see you folks back here in about 10 minutes. On the recording here. All right, so can folks see the Desmos screen right now? Perfect, thank you so much. All right, so one of the functions that we took a look at earlier, so let's type in the equation from example number 9, okay? So we're gonna write y, we're gonna type in y equal, and then I'm gonna open a parenthesis. If you want to type square root, you can do SQRT, okay? So SQRT turns into a square root symbol on Desmos, X, and then you're going to move out of the square root, -3. If we close that and then we do a divided by, it turns into a fraction for us. And then we're going to type in the denominator of our example number 9. So we get X -9. Okay. So that is how you can type an equation into here. And as soon as you type in your equation, you can see that a picture starts to show up on the on the right-hand side. And so what was the X value that we were trying to get close to in example number 9? We were trying to get close to 9. Okay, so I can sort of zoom in a little bit here. And maybe zoom in. Okay, and one more time. Okay, so we see X equals 9, right? That's our horizontal axis. Now, anytime you click on the graph, it gives you the coordinate of the point. So here at 8, the Y value would be 0.172, probably with some other decimals, but it tends to end it after 3 decimals. So let's see what the value is at 10. 10, get 0.162. Now let's go and see what happens at 9, okay? And check that out. So there's actually a hole at x equals 9. That's why when we plugged in 9, we couldn't get a value out, all right? But instead, what we wanted to try and find is what's happening on both sides of the function. And it turns out that we get close to 0.167 from the left. And let's see what happens when we come from the right. We can watch that y value change. Oops. It also gets close to 0.166, 0.167, okay? Now, what was our answer that we got in example 9? Like after we used the conjugate and after we simplified, we got exactly, Sophia, we got 1/6, okay? You're not sure what 1/6 is as a fraction or as a decimal? Let's go ahead and type it in. I do 1 divided by 6, 0.1666. Okay, so what we were finding when we used the conjugates and did all of that complicated math is we were saying, what y value is the function getting close to as you get close to 9? It gets really, really close to 1/6. And that's why our numbers, our answers are different. Like we have undefined because at that point it's actually a whole, but from both sides of the function, we actually get an actual y value. All right, so hopefully that puts it into a little bit more context, like what we're trying to do and why we get different answers when we factor and reduce, or when we use the conjugate and reduce. And the purpose of that is to avoid getting just the whole, but we want to find what's happening around that weird point. Okay. As you're working through the quizzes, it's totally fine to throw all the questions on Desmos and see what that picture looks like, just especially if you feel like you're a visual learner. I know it's easy to get lost in all of the algebra, but we can always use Desmos to kind of boost that understanding. Like, what is it that we're looking at? What does it look like? Why are we getting the answer we're getting? Okay, so I hope that was a little bit helpful. And let's actually, before we close out of Desmos, I'm going to type in the function for number 11. That's going to be the next example we do, okay? So let's see how we can use Desmos to kind of visualize what we're looking at before we actually get to the algebra, okay? So I'm going to type in y equals, I'm going to have parentheses, 1 over x plus 1 minus 1/2, close it. That's the numerator of the next problem we're going to work on, divided by the denominator is x minus 1, okay? So anybody ever seen a function that kind of looks like that before?
Is that just like 1 over x?
Yeah, exactly. So from pre-calc, you probably have seen something that is the 1 over x function. Exactly, some people call it a rational function. And what are some things that happen with rational functions is we actually end up with some asymptotes. So we're going to talk more about these asymptotes tomorrow. But what we're going to find in this particular problem is that we actually have a weird missing point, okay? So if anybody has the notes pulled up, what x value are we looking at for this very complicated looking function? Perfect, thanks folks. We are looking at x equals 1. So let's go to x equals 1. It is undefined. Okay, so when we plug in 1 to this function, we should get 0 over 0, okay? Now let's zoom in a little bit. And let's just start dragging this point along. And let's see if we can predict what our answer should be. As we get really close to x equals 1, yes, Desmos can draw piecewise functions too. I'm happy to show you how to do that, maybe like after class, or you can ask me on Discord. I can help you with that. All right, so what y value do you think we're getting really close to here from the left-hand side?
Negative 0.25, negative 1 over.
Yeah. Oh, awesome. Awesome. Yep. Perfect. That's fine. We always miss a decimal point somewhere. Yes, but it is about -1/4, negative 0.25. Okay. And sometimes it helps to check from the other side so we can kind of see a little bit better. Is it indeed getting close to? Yeah, it looks like it's getting real close to negative 0.25. Okay. So what have we learned from this Desmos? One, we should get 0 over 0 when we plug 1 into our function. All right, so we're going to show that in just a bit, but prediction wise, we want to say it's okay if we get 0 over 0. The second thing that we want to hope we do get is our answer, or let's say our limit should be -1/4. All right, so from our graph, we've told ourselves, okay, it's okay to get undefined, and here's what our answer should be. Now we just have to make sure that we're able to do all of the algebra to get that answer, okay? So if this kind of style works for you, definitely use this on the quizzes, all right? Look at the pictures, think about what it should be, and just make sure that your work matches that, all right? So let me switch sharing back to the other screen. All right. Are we all seeing the notes?
Yes.
Yes, awesome, thank you. Let's see, Luca, how should we show that? You don't have to say this is my prediction. You can sort of like, it's almost for your own sake, you can know that your answer is right. Does that make sense? So I think a lot of times when we're doing math, especially math that might be newer for us, we're like, I don't know if my answer is right or not. Desmos gives you a way to kind of predict and double check that answer. Perfect. All right. So now here is example 11, and let's jump into some algebra and fractions. Super fun times. All right. So this fourth case right here is called complex fractions. And the reason it's called complex fractions is because we have fractions inside of other fractions and we have to somehow simplify this, okay? So before we do that, let's go ahead and substitute in our number just to make sure that we're good with our arithmetic. So we'll get 1 over 1 plus 1 minus 1/2 and 1 minus 1. Okay, 1/2 minus 1/2 gives me 0. 1 minus 1 gives me 0. We have our undefined. This matches perfectly with our prediction and what Desmos said, right? Desmos says there's a hole in this graph here. And when we substituted in our numbers, we got proof that we have a hole there, all right? Now, let's talk about these fractions, all right? Now, I don't see any quadratic expression, so I'm not thinking factoring like the first one. I don't see any radicals, so I'm not thinking conjugates, but I do see fractions, so I'm thinking, how can I turn that into not a bunch of fractions inside other fractions, but just one fraction? Like just one fraction would be way easier for us to think about, okay? So I'm going to write it this way. You're welcome to write it in your own way, but I think that sometimes fractions inside of other fractions is like just too much for the brain to handle. So I'm going to take, oops, I'm going to take this denominator, x minus 1, And I'm going to bring it out to the front, and it's going to look like this: 1 over x minus 1. And the reason I put a 1 over it is because x minus 1 is in the denominator. I want to keep it in the denominator. Okay. And then I'm going to write the numerator. So 1 over x plus 1 minus 1 half. Okay. So let me just pause here for a moment and see if there are any questions about how I wrote this or why this is okay.
You basically just separated the numerator and the denominator into two different fractions.
I did. That is a great way to summarize that. So let me write down what you just said. Basically, exactly like Matt said, I took this denominator and I brought it out into one fraction. And then I took the numerator and I made it a separate term. Okay. Would it be bad to actually divide it and multiply by the reciprocal? That is actually another way of looking at this, right? So since I'm dividing by x minus 1, I want to multiply by that reciprocal. I actually love the way you said that. Right, so the reciprocal of x minus 1 is 1 over x minus 1. And maybe if we put a little multiplication dot in here, that would be a little easier to see. Is that what you were asking? Ah, okay. Okay, perfect, thank you. All right, are there any other clarifying questions about how I did this magical split into two fractions? Okay, well, if you think of any later, we're gonna try a couple more examples. So it's totally fine if you ask again later, okay? All right, so at least for me, when I have fractions and it's sort of like a long string of fractions, that's easier for my brain to handle than when they're sort of stacked all together. Okay, so I made it longer horizontally, but it made it easier for me to see all the numerators and all the denominators. All right. Now let's start with this piece right here. Okay, the part inside the bracket. I have two fractions. I'm subtracting them. Okay, so maybe let's do a little throwback to elementary school or middle school. I've got 1/2 and I want to subtract 1/3. How do I proceed?
You create the lowest common denominator.
Common denominator. Perfect. Great job, Sherwin. Common denominator. And I love how specific you were, Matt, that we're looking for the lowest common denominator, right? I forget who it was earlier who asked, like, are we going to be looking at super big numbers? We want to try and keep those numbers as small as possible for ourselves, right? So our lowest common denominator here is going to be 6. What do I get for that first numerator?
3.
I get 3. All right, so 3. And for the second one?
2.
2. Okay. And I get 1/6, right? So when I find my common denominator, I get to keep that denominator and then I just manipulate the numerator. All right. I know that these numbers are fairly straightforward, but I'm wondering if we could add in a step that maybe we needed when we first learned about common denominators. So maybe if we had a question 1/2 minus 1/3. What would I multiply the first fraction by to get that 6 in the denominator?
3/3.
3/3. All right, so 3/3. And the second one I would multiply by 2/2, right? Now with fractions, we don't necessarily need these, like with numbers, we don't necessarily need to do that step. But I think it's important to remind us how we do things when we have a lot of variables. All right, so let's see. If I want to find a common denominator inside of that bracket, what would I multiply the first fraction by?
By
2/2.
2.
Yeah, we're gonna do a 2/2. And what do I multiply the second fraction by?
X plus 1 over x plus 1.
I love it, I love it. Okay. So now we've got a structure that looks super similar to what we had in the purple with the number, right? The blue 3/3 is very similar to this, right? We're multiplying by something to get that common denominator. All right, well, let's clean up that inside fraction. Let's see, we're gonna get 2/2 times x plus 1 minus x plus 1 over 2 times x plus 1. All right. What do you think would be the number one mistake when people simplify and combine those two fractions inside the bracket?
Probably a failure to distribute the negative sign to everything in the x plus 1.
Yeah, great, exactly, Sophie, perfect. So I bet the number one mistake I would see is someone would be like, oh, 2 minus x plus 1 is 3 minus x, right? But as Matt so eloquently said, we have this minus sign. We cannot fail to distribute that. We need to make sure we distribute that, right? So we need to take that negative, we need to distribute that to everything there. That's going to change what we have in here. And in fact, that's going to change it, I think, for the better, because we're going to get, instead of 3 minus x, we're going to get 1 minus x. Okay. Now, I would say this next sort of algebraic trick that I'm going to show you is one of the ones that gets you a lot of mileage. It tends to come up quite a bit, okay? Let's do a little pattern with numbers up here. I love all the color options here, but sometimes there's too many colors to pick from, and I don't know which one to choose. But let's try this color. Okay, what is this? It's not a trick question. Okay. And what is this?
-1.
Mm-hmm. Okay. What is this?
2.
Uh-huh. What is this?
-2.
Okay. What is, let's skip a few. What is this?
9. -9.
Mm-hmm.
8.
Mhm.
Hey, it's -8.
Okay. So can someone describe to me the pattern that they might be seeing between these pairs of addition problems?
Reversing the terms and keeping the same sign will net you the
Exactly. So you might notice that I used all the same numbers, right? 2 and 1, 1 and 2, 3 and 1, 1 and 3. And all I did was change the order in which I asked you to subtract them. Okay. And it turns out they all had the same answer, except the signs were different. Okay. So a general way that we can say that, let's shrink this down for a bit, is if you have, let's use A minus B, and let's say that is equal to C, what is B minus A equal to?
-C.
Negative C, exactly. Okay. So switching the order there means that I'm going to get the same numerical value, but it's going to have a different sign. Okay. Now, is this fair to say? Let's see, -1 times A minus B. What is that going to give you?
-C.
Negative C. Okay. Okay. All right. So here's why all of this is important, right? Let's go back to our question for a moment. 1 minus x. So close to x minus 1. And I think it was Noah earlier who said, oh, can we reduce if they're sort of the same, but not quite? X minus 1 and 1 minus x. I can reduce those, but it doesn't reduce to 1. What does that reduce to?
-1.
Yeah, it reduces to a -1. Okay, so anytime you see things that are like so close to being similar, 1 and x, x and 1, but the order in which you subtract them is different, you're able to reduce those terms, except they reduce to -1. They don't reduce to a +1. Okay. So for example, running out of some space here. For example, if I said 2 minus 5x, and then I had 5x minus 2, what does that reduce to?
-1.
Okay. What about 3x minus 7? What would I put on the bottom to make sure it reduces to -1? Yeah. I would switch the order. So 7 in the front, 3x at the back end, and then subtract. Okay. So that's a really useful pattern, especially when you're looking to reduce factors and you're like, ooh, if only they were in the opposite order. Turns out you can compensate for that by just saying they reduce to -1 instead. Okay. So if we go back down to our problem, we've reduced that to be a -1. Let's see what we have left. The limit as x approaches 1, I have a -1 over 2x plus 1. And now let's try plugging in our number again. Okay. We plug in our number, -1 over 2 times 2. -1/4. And I'm so delighted because we used Desmos in the beginning. We kind of knew where we were headed, and we achieved what we want to achieve, which is that the limit from both sides, or that y value from both sides, is actually getting close to -1/4. Okay. Now, you could certainly use Desmos in the other order, meaning that you can work through a problem like this, and when you're done, check your answer on Desmos and see, did your number match the picture version? Okay. So I know this was sort of a longer problem. We took a few side steps to look at some patterns and numbers. How are we feeling about this particular example? And it's okay to say terrible, okay? I think sometimes when everyone else is saying, seems really great, you're like, it seems great too. But if you genuinely don't feel that way, you can always send me a private message and say, I don't really understand what's going on, okay? That is sort of the nice thing about being on Zoom. You can actually ask a secret question and no one else has to know. All right. You can also ask me later on Discord. That is also fine. Okay. Either way, let's try another example. Okay. And let's go ahead and try example number 12. Okay, so example number 12, sort of similar in structure with a few small tweaks. And so let's see how those changes impact our problem. And this time we'll sort of do Desmos in the reverse order. Okay, so we'll solve this first and then we'll put it into Desmos and see whether we can confirm our answer or not. Okay. So first things first, let's plug in the number at hand and see if, and let me actually shrink this down a little bit. Sorry, the spacing is always like, you kind of hope it's going to be enough, but you're never really sure. Let's just copy this to the other page. Okay. All right, so we want to plug in -3. We want to be really careful with our signs, and let's see what happens. So 1 over -3 plus 2 plus 1 all over -3 plus 3. Okay. And when we look at that, I think we can sort of see that we are going to be getting 0 over 0. I think the denominator is a little bit more straightforward, right? -3 plus 3 gives us 0. The numerator, we just got to be really careful about our signs. We get 1 over -1 plus 1, which gives us -1 plus 1, which gives us indeed that undefined. Okay. What if I plugged in the number and I actually got a number back out?
You'd be done.
We'd be done, right? We'd be like, thank you, Judy, that was such a generous test question. Thank you for just making it so all we had to do was plug in the number, right? So we want to make sure we do this step, even if it's in our heads, we want to make sure we check before we do more complicated things, okay? All right, so I don't see quadratic expressions, so I'm thinking I don't want to do factoring. And I don't see any radicals, so I'm not thinking conjugates, okay? I do see a bunch of fractions, so maybe I want to think about rewriting this instead of a fraction inside of another fraction. How can I make them so it's sort of a long line of fractions? And using Luca's language from earlier, I really like how you said dividing by x plus 3 or dividing by that denominator means that you're going to multiply by the reciprocal. So if you're dividing by x plus 3, you're going to be multiplying by 1 over x plus 3. And inside of my brackets, I'll have 1 over x plus 2 plus 1. Okay. Now we need to make a common denominator. Let's see. What do we think that common denominator will be in this particular case?
X plus 2.
X plus 2, perfect. All right, so 1 over x plus 2 plus x plus 2 over x plus 2. All right. You know what? This problem is a lot friendlier actually, because we don't have any minus signs. I feel like it always gets so much trickier when we have negative signs, because if we don't distribute, we might not get the right answer. But with addition, it doesn't really matter which order you do it in. So we can just sort of add straight across. And let's see what we get. One over x plus 3. And we're going to get x plus 2 plus 1, which is 3, over x plus 2. All right. Now, you folks have been really good about not making these mistakes, but I just want to, I'm a big fan of showing you where these common mistakes are so we can think about not making them. If you did this, bad news bear, don't do that. Okay. So you're taking a factor that is secretly inside of parentheses and you're breaking it up and making it into separate pieces. All right, so that's a little bit of a illegal algebra move here. What could we reduce though, if we include those secret parentheses in our head?
The x plus 3 terms will cancel.
Yeah, this factor and that factor. Okay, perfect. Thanks, Joey. And we will get the limit as x approaches -3 of 1 over, right? Because we're not going to make that mistake. We know that x plus 2 is in the denominator. It has to stay down there. And excellent. All right, now let's plug in the number and let's see. 1 over -3 plus 2, 1 over -1. Yes, and we should get -1. Perfect. All right. So what this means then is when we put this very complicated looking function in on Desmos and we go to x equals -3, we should see -3 comma undefined on Desmos. And when we click and drag points that are on the left side or on the right side, those y values should get really close to -1. Okay. Now, before we take a look at that graph and we take our short second break, quick question for you. What if I got to the end of the that first line and I ended up with this instead? What if this was our problem? How would we simplify this?
The 3 minus x and x minus 3 terms will cancel to be -1 rather than 1.
Perfect. These two would reduce, but to a -1, whereas this one reduced to a +1. Okay, so what if? Great ways to study if you're like, I was able to do this question, but what if we changed it to this other question? Okay, so let's throw this picture on Desmos. Let's confirm our answer. We'll take a short break before we resume and see how far we get for the rest of today. Okay, so let me stop this share. Let's, okay. So let's graph our function. I bet I can just modify this. So 1 over x plus 2 plus 1 over x plus 3. Okay. And so we see sort of a rational function here. By the way, what is this called? Let's see, I can annotate on my own screen. What is this called? This line that we don't see here, but is actually an important feature.
An asymptote.
Perfect. Ooh, and folks are spelling it correctly. Nice job, nice job. In particular, what kind of asymptote is this?
Vertical.
It's a vertical one. And if we were to imagine this blue line, that would be also an asymptote, but of the horizontal nature, okay? Again, we'll talk more about the asymptotes tomorrow. Let me clear those drawings real quick. All right, so we are trying to see what happens when we get to -3, right? So I'm gonna go on the screen. Let's get a little closer to -3, all right? And we're gonna go to our picture. Oh, there it is. And you can see that they also, like if you click on the undefined point, there's a little open circle that pops up. I wish they made it more obvious on the graph, like you didn't have to click on it to see the little hole there. But if you can get it right on that value, you'll see that we have our undefined, which is awesome because we got 0 over 0, right? So we expected to see a hole here in the graph. Now let's see what, if we click from the left-hand side and we drag it really close, and let's see these y values. Oh, yeah, that looks really close to -1, right? -0.9775. And let's see if we click and drag from the other side. Yeah, that gets really close to -1 as well. Okay, so you can, I would encourage you probably to do the problem first and then check your answer. But if you're feeling completely lost and you just want a little extra support, it's fine to try it in the other order first, you know, sort of know where you're going and feel a little bit more confident as you move into the problem. Okay. So how are we doing here? You feeling okay about fractions, terrible about fractions? Okay. And again, it's completely fine to send a direct message and be like, it's not fine, it's so bad, okay? Okay. So let's do this. It is 8:53, okay? Let's take another break. So let's come back at 9 a.m., all right? And then we'll do our cruise to the finish. We are going to finish up one more question from the notes, and then one of them will actually be sort of like a bonus if you want to work through it. And then we'll answer questions. I know there are questions about exams. I know that I said I would talk about extra credit today, so let's do an example, and then we'll wrap up class with some important announcements. All right, so I'll see you folks back here in about 6 minutes. All right, so before we work on our very last problem for today, I do want to put up here that example 8 is one problem that you can try on your own. Okay, I think it's a little bit sort of a combination of example 9 and 10. And so if you're feeling that radicals are not your forte, this could be another great one to sort of try. Once you've tried it, you can message me via Canvas or on Discord. I'm happy to confirm your answer. You can also confirm the answer for yourself by putting it on Desmos and seeing what that gives you. Okay. If you are feeling like there's a discrepancy between Desmos and your answer, I'm happy to help troubleshoot. The more you can sort of lay out your work, each individual step, the easier it is for me to troubleshoot that work. Okay, so I'll leave example 8 here for you to sort of try on your own. But the last question we're going to take a look at today is example 13 here. Okay. And so with example 13, we've got yes, we are doing 13. All right, so we're going to do 13 together. We'll go through the algebra part. I'll leave it for you to check on Desmos on your own to confirm our answer. And we'll start by just plugging in the number. All right, we'll do a quick check to make sure we need to do extra work. And so if we plug in our number, we'll get 1 over square root of 4 minus 1/2 over 4 minus 4. And we get 1/2 minus 1/2 over 4 minus 4, which very clearly leads us to our undefined. Yes, undefined. All right. And we've got our undefined, so that means we're going to need to use some other strategies. Okay, so let's start off by rewriting this for ourselves. And so I'm going to bring the x minus 4 into the front as 1 over x minus 4 times 1 over root x minus 1 over 2. Okay. And now I'm going to try and find a common denominator. All right. So let's try and find our common denominator. What should we multiply the first fraction by? And what should we multiply the second fraction by? 2 over 2, great job. 2 over 2 for the first one. That means we'll have a denominator of 2 square root of x. So how do I make that happen for the second fraction? Perfect. I love it. Yay. All right, so we've got our common denominators now. Now we're able to simplify that a bit. So I'm going to get 2 over root 2 root x minus root x over 2 root x. And I know that I can't combine my 2 and my root x because they're not like terms. So my numerator inside the bracket will just be 2 minus root x over 2 root x. Okay. All right. So if I were to write this all as a single fraction, I would end up with the following. 2 minus root x over 2 root x times x minus 4. Nothing is canceling out, right? In our previous problem, after we made the common fractions or combined into a single fraction, we were able to reduce something. But in this case, we might notice that nothing is reducing, and we might panic a little bit. Sherwin, can you tell me a little bit more about that? Looks like the x minus 4 can be changed. And I know typing math takes a little bit, so take your time.
I'm just gonna use my mic instead because I can't type all of it.
Okay.
Would it be possible to use to square root all of it, or would that complicate it more? Because it looks like if you could get square root of x minus square root of 4, which would be 2. So square root of x minus 2, I'm not sure if that would complicate the 2 square root x more though.
Okay. I love that you were able to identify the x minus 4 as something that we can change, okay? This is a little bit different than what we've been talking about with the conjugate, but it is actually the same idea, okay? So if it's okay with everyone, I'd actually like to show you sort of this alternative method, perhaps we call it the Sherwin method, okay? Where we can, instead of multiplying by a conjugate, sometimes if we just factor an expression, we can actually achieve the same goal, okay? And so almost, Vincent, okay? So when we think about this, let's keep the numerator the way it is, 2 minus root x. And we'll have this 2 root x. But I'm going to take x minus 4 and I'm going to factor that. Okay. So let's leave a little note for ourselves. We're going to factor that. Now, Vincent, I love that you put that in order to get x, we would have square root of x and square root of x. And I see a direct message here. Perfect. How would I get 4 by multiplying these last terms? Because I wouldn't do square root of 16. That would give me 16. How would I get
Minus 2
these
plus
last
2.
2 plus 2? Yeah, there we go. Okay, so plus 2 minus 2, all right? So factoring, again, we'll have an activity on Thursday that deals with factoring, but factoring is definitely something we want to be practicing outside of class time, especially if it's something we don't like, okay? One of those, like, if you put in the time now, it is going to pay off huge for you in the future. If you keep hoping it'll go away, I have real bad news for you. It's not going away, okay? So we factored this, right? So we didn't have to use the conjugate. And we can even use another trick we learned today. What trick can we use here to simplify? Because I would say there is one thing that we can reduce here.
You can reduce the numerator and denominator.
Perfect. 2 minus root x minus 2. Excellent. Those we're going to reduce to a -1. Love it. Okay. Let's, oh, I have all this room over here. I forgot. Limit as x approaches 4. -1 over 2 root x, and then root x plus 2. As messy as it is, let's plug in our number and see what we have. -1 over 2 root 4, root 4 plus 2. Do a little bit of mental math, and I think we should end up with -1 over 16. Okay. So this second method that we've highlighted here about factoring instead of using a conjugate, if you don't really like using conjugates, but you like factoring, this is a very viable alternative method, okay? I'll leave you to check this on Desmos on your own, that there is indeed a hole at x equals 4. that the y values on both sides of that get to -1/16, okay? And I'll also leave you to consider, how do you know when to use all the different methods that we covered in this particular section, okay? Before we leave these notes, are there any questions about anything that we've covered today?
Professor, on the factoring where you have the square root of x plus 2 and the square root of x minus 2, how did you get the square root whenever
gonna say-
it's just x plus 4 or x
That's
minus
a-
4 rather?
That's a great question. So normally when we factor, we sort of see things like this, right? Like x squared minus 4. And we know that factors into x plus 2 and x minus 2. And we got the x because in order to make x squared, we need x times x. And so we're almost taking it down a level where we're saying, well, it's not x squared minus 4, it's x minus 4. So if I keep this as x plus 2 and x minus 2, the first terms when I multiply them won't give me x. So instead, I need to say square root of each of those. Now, square root of x times square root of x will give me the x.
Okay, that makes sense.
Okay.
Thank you.
You're welcome. All right. Okay, great. Okay. All right, so if there are no other questions right now, it is, again, okay to have questions later. I think a lot of times we sit down to do our own questions and then we're like, oh, yeah, I didn't get that part. Okay, and that is totally fine. It is to be expected. This is an accelerated summer course. We don't have a lot of forgiveness in terms of time. And so if we sit down later to do some work and we get stuck, it is okay to ask for help, all right? So let me stop sharing my window here then. And a few announcements to finish off class today. So, okay, so announcements. First, there is a limits and continuity activity on Desmos, and that is due by midnight tonight. Okay, so you're going to want to make sure that you've signed up for the Desmos class. You can find all of that information in the Canvas shell. Okay, I know that if you are not on the Discord server, you can also join that, and you can ask me, you can ask anyone on the server, all kinds of clarifying questions. Okay, so limits and continuity activity on Desmos is due by tonight. All right. Number 2, if you missed the scavenger hunt, I will still accept scavenger, oh, that's not how you spell it, scavenger hunt assignments until midnight tonight. All right, so I'm not trying to ding anyone on the first assignment. I know that we're all adjusting to a new schedule, but there were a few folks who missed that assignment. I don't want you to be like a negative 10 points on the very first day. So go ahead, look at that scavenger hunt, complete that assignment, and turn that into Canvas by midnight tonight. Okay. Exams. So there was a question about exams earlier. So exams will be given during class time. You can sign on to Zoom or not, your choice. Okay, I will be here during the exam time. I think one of the hardest things about taking an assessment online is that if you have a clarifying question, you can't just walk up to your professor and ask them, right? And you might just be so confused on the direction. So I will be here during exams, during class time. Some people like to sign into Zoom and just hang out here and do their exam. That way, if they have questions, they can just ask me right away. Other people like to sort of do their work, and if they get stuck, then they'll sign on to Zoom. And other people are like, I just don't have any questions, I'm not going to sign into Zoom. All three of those versions are fine. Okay, so if that's what you were asking about proctoring, I hope that clarifies the exam structure. Are there any other questions about exams while we're talking about that?
Exams, we're going to be like submitting PDFs exams, or what's the input method for our assessment?
I'm sorry, I don't know if it's my end, but you were breaking up a little bit. Do you mind either repeating that or typing that in the chat? How will you be inputting answers onto the test? Okay, great question. That actually pairs really well with that second question about whether they're multiple choice. I'm not a fan of multiple choice. I feel like that tells me very little about how you act, what you actually know and what you don't know. So it is, yeah, it's much easier to grade though, I'm not gonna lie. But that is a decision I made in my career that like, it's more important for me to know what you know and what you don't know than how well you can choose one of 4 answers. Also, when I took calculus in college, our tests were multiple choice, but it was A through double Z. Like there were 40, 50, 52 choices for every question. It was like every sign mistake you can make in the entire problem was an answer choice. Yeah, so on that end, I was very scarred, and I will not do that to you. So, okay. So our exams are going to look sort of similar to questions we do in lecture and questions we do in quizzes. And so the way it'll work is when you sign into the exam, it'll be an assignment on Canvas. It'll be released at 7 a.m. and there'll be a PDF link. And so you'll click on that link and it will, yeah, I think there's a little buffer time just to make sure that like technology is working, you know, like it's just, I think I wanted to give a little bit of a buffer there. Okay. So exam time, 7 to 9:30/10, okay, in case we run into any technical issues. But the questions will be more like open response, explain your thinking. I know that some folks hate that about my exams because I actually asked you to tell me about the math and what you know about it. But if you listen to the way we're talking in lecture and the questions that I ask and the way you answer them, all of that is preparing you for the exam, okay? So as far as the questions, how many of you have access to a printer or a tablet? All right, and so okay, so folks who have access to a printer or tablet, that is something you can print out the exam, you can write on it, like if we were in class and I gave you a handout, and that would be fine. Or you can download the PDF, you can upload it to your tablet, and you can write right on there and then turn that in. If you have neither of those, then your options, you can just look at the questions on the screen, you can write your questions on paper, and then you can take pictures, turn it into a PDF, and submit that. Okay, so you're not typing any answers into Canvas, and I hope that makes people feel a little bit more comfortable with that. Okay, so the way that you do your quizzes is very similar to how you'll do your exams. Okay. All great questions. All right, so are we starting the day 2 sheet tomorrow? Yes, Vincent, we are. That leads very well into Joey's question. Is the Desmos activity the one from yesterday or is it a new one? It is a new one, okay? And it will actually be really great for you to do that and then we'll talk about the continuity tomorrow. So we'll put actual names on the things that you're looking at, okay? So there is a new activity on Desmos. I saw that some of you already did those between the time I uploaded yesterday's and this morning, so that's awesome. And yeah, so go back into Desmos, check for that activity, go ahead and complete that. Will the quiz on Wednesday cover yesterday and today's class, and the quiz on Friday cover tomorrow and Thursday's class? I think this week we're going to be a touch off. I think the quiz due tomorrow at midnight will cover stuff we've done today, as well as a little bit of stuff we'll do tomorrow. Okay. And Noah, that is the limits and continuity. Okay. So not the first one you said, but the second one you said. Okay. All right, I think the last thing I wanted to talk about in like the 60 seconds I have left is extra credit. And extra credit looks like this. There's sort of two variations, all right? First, on exams, there will be a bonus question, okay? So on each exam, you can expect a bonus question. And that will be one form of extra credit. Second, there will be, let's say you don't do well on an exam. So this is less extra credit, more like what happens if I do poorly on an exam. So if you do poorly on, if folks overall do poorly on an exam, I may offer test correction. Okay, and what I mean by that is you'll have an opportunity to make your corrections, like what did you get wrong, make your corrections, but then you schedule a meeting with me and you talk to me about what mistakes you made. And it's sort of like an interactive case where you sort of show me how you corrected your mistakes. I might ask you some clarifying questions to make sure that you understand why you made those mistakes, and to make sure that there's not like a concept that you're holding on to that's incorrect, okay? So depending on the exam, I may offer test corrections, and then you have a chance to boost your poor test grade. Okay. I know that timed exams are not the best way all the time to know, for folks to know, like show what they know, okay? There is a limit in terms of, there's a limit in terms of how many points you can buy back. Typically, it is 50% of the points you lost, you can earn back, okay? So let's say you lost 50 points, you can earn up to 25 points, but that is the typical. So I try and leave it a little bit flexible. Okay. All right, I know that we are officially over, so if you have to go, that is totally understandable. I'll answer this one last question, Johanna, if you have a study guide. I post a topic list, so I tell you what topics they're gonna be. I don't post like a study guide with problems, okay? Yes, Sophia, you can email me or message me on Discord and I will be happy to help you out. All right, bye, Brittany. Bye, Kristen. All right, bye, folks. Have a great day.